So in this case, we're going to look at a more complicated equation, du dt plus u du dx is equal to 0. So earlier, this thing here was a constant c, but now it isn't. It's a variable. So this equation now is nonlinear, which makes it more complicated to solve. So we do the same approach as before. The spectral method will assume, let's see. Yeah, nonlinear. And so we'll assume the usual sigma d sub m of t e to the I m k x kind of thing over little m, and of course u is equal to this, and we'll worry about the finite m's in a few moments. So if we substitute this into the first term, then we come out with the time derivatives of the expansion coefficients. But if we substitute this into the second term, we get a giant mess. So let's have a look at the second term. It's going to be u itself, so the sum d sub m e to the I m k x summed over m multiplied by a second piece, which looks like the sum. Now we don't need to use the same character here, so we'll have the sum over d sub n times I n k e to the I n. Distracted there. E to the I n k x. Okay. All right, so what do we have here? Okay, so what we have here is a big mess associated with this product. I think I mentioned in class the other day, let's just find a little piece of space up here, okay? If you have m terms in the expansion, m of these and m of these, then you have m squared product terms. And that ends up being a large number, which just doesn't work for weather forecasting. In fact, let me pull up another slide and just reinforce that idea. And I think this is something that we talked about in class the other day. So the current GFS model is spectral. And it has 1, 5, 3, 4 waves in it. That's the resolution. We're going to talk about this in just a minute, okay, what that means. But so if that's m, then I think I mentioned in class that m squared is, 2,353,156. So you have to do that many calculations every time you run into a nonlinear term at every time step, and it's way too computationally demanding to be useful. And so it's because of this that we use a new approach. And that new approach is called the transform method. This is why we use what it's called the transform method, and it's my job now to tell you what that is. Okay,